Hi guys, it's one and only maths favorite teacher once again. So on this session, we'll be basically applying some of the geometrical laws in order to calculate the values of the unknown. So this video will be mainly based on Theorem 6 that states that the exterior angle of a cyclic quad is equal to the opposite interior angle. So let's solve what we are supposed to do. So here, the first thing that we're going to do, you're going to start by determining. So remember, there's no procedure that one can follow, right? You can determine angle J or you can just determine angle G. So I'm just going to say angle J plus 106 degrees plus 106 degrees. It's going to be equals to 180 degrees. So don't forget, in geometry, each and every statement should be accompanied by the reason. So this one is adjacent angles on a straight line. Adjacent angles on straight line. On straight line is TR. Then when you continue, here you're gonna say angle J is equals to, then you say 180 degrees. Then you take positive 106, you transpose it that side, it changes the sign to become minus 106 degrees. Then therefore, angle J, put the copy, since it represents an angle, it's equals to, then you take your calculator, you subtract 180 minus 106. What are we getting? So we're gonna get 74. So it means to say angle J is equals to 74 degrees. So it means to say that is your angle J. So if you want, after solving each and every unknown angle that you're required to solve, you can go back and put it on the diagram. And then, since now we have angle J, you can now consider determining angle G. So when you determine angle G, this is what you are supposed to do. This, and remember, here there will always be parallel lines. I forgot to put that. So let's continue. So after getting angle J, let's now find angle G. So I'm just gonna say angle G, as simple as that. It's equals to what? It's equals to 106 degrees. So this one, it will be exterior angle of a cyclic quad, angle of cyclic quad, exterior angle of a cyclic quad is equals to the opposite interior angle. It's equals to the opposite interior angle. It's very key that each and every statement, after writing it, it is accompanied by the reason, right? And then it simply means to say our angle G, that's 106 degrees. And then after that, you now continue. You can now solve angle H. So I'm just going to say angle H plus angle J, it's equals to 180 degrees. So the reason why I'm saying angle H plus angle J is equals to 180 degrees, this is co-interior angles are supplementary. Co-interior angles are supplementary. So to those who don't know what the supplementary angles are, supplementary. Supplementary. So to those who don't know what are supplementary angles, when you speak about supplementary angles, these are angles that add up to 180 degrees. And then from here, we are solving for H. I'm going to say angle H plus, and then since we got angle J being 74, we can now write 74 degrees there, as easy as that. It's equals to 180 degrees. And then you're going to say angle H, put the copy, since this represents an angle, it's equals to is equals to, then you write 180 degrees, and then you take positive 74, transpose it that side, changes the sign to become minus 74 degrees. Therefore, then you say angle H is equals to, and then from here, we all know that 180 minus 74 degrees, we're going to get 106 degrees. So you write 106 degrees. So it means to say our angle H, that is 106 degrees, right? Then now we are left with determining angle I. We are now with determining angle I. So I'm just going to use or utilize this space right here to solve the last angle, which is angle I. So from here, I'm gonna now find angle I. So if you want, you can also consider start writing it like this. You're still gonna be correct at the end of the day. If you can just say angle B plus angle C is equals to 180 degrees. Don't forget, each and every statement should be accompanied by the reason. So this one, it will be opposite interior angles of a cyclic quad are supplementary. Interior angles of cyclic quad. Cyclic quad supplementary. Supplementary, just like that. And then now we substitute. In a place of B, angle B is represented by H. So you can write H plus, then angle C, it's represented by I. It's an angle, you put a cap on top, it's equals to 180 degrees. And then after here, guys, we all know that our angle H, we got 106. So that will be 106 degrees plus, let me write it like this, yeah, 106 plus angle I, it's equals to 180 degrees. Then I'm going to say angle I, it's equals to, you write 180 degrees. Then remember, you take positive 106, you transpose it that side, changes the sign to become minus 106. Minus 106 degrees. Right? Then after that, you're going to say, therefore, angle I, it's equals to what? You say 180 minus 106. That should give you 74 degrees. So you can consider writing 74 degrees, right? So that's 74 degrees. So that's how we solve this. Then coming back to the second diagram. So on the second diagram, what we are required to do is still the same question, calculating the values of the unknown, right? So now as you calculate the values of the unknown, we have parallel lines right there. So one thing that you can start to do here, I'm going to say in triangle ACB. So in triangle ACB, the first thing that you can do, you can actually know that AB is equal to the what? It's equal to the diameter. AB is equal to the diameter. So even if they didn't tell you that AB is a diameter, by just mere knowing that O is the center, you know that OA is going to be a radius, OB is going to be the radius, and diameter is equal to 2 times radius. So this basically means to say AB is equal to diameter from here. And then we know that according to Theorem 3, it means to say, I'm going to conclude to say angle X. I'm going to now conclude and say angle X, it's equals to what? It's equals to 90 degrees. So the reason I'm saying angle X is equals to 90 degrees is because of it is based on Theorem 3. Theorem 3, that is going to be angle in a semicircle. In a semicircle. So angle in a semicircle, that's going to be 90 degrees. So if you don't understand what is Theorem 3 angle in a semicircle, just go back to some of the videos that I posted. That is where I explained how do you get angle in a semicircle. So when you speak about the semicircle, it's a half a circle, right? So we know that angle x is equal to 90 degrees. And then after now knowing that angle x is equal to 90 degrees, we know that you can put that box there that represents 90 degrees or perpendicular or at right angles, because at right angles is 90 degrees. Then that's when now you can consider solving other angles. So I'm gonna now say angle A, it's equals to what? It's equals to 68 degrees. So this is exterior, that is exterior angle of a cyclic quad, exterior angle of cyclic quad. Cyclic quad is supposed to the opposite interior angle. Opposite interior angle, right? Then after there, we can see that our angle A is represented by L. So it's gonna be L. We can just consider writing therefore angle A, L is equals to what? 68 degrees. So it means to say our angle L is 68 degrees. Our angle X is equals to 90 degrees. And then from here, I can now determine the value of K. So still on triangle ACB, I'm going to get K by using sum of angles in a triangle, right? So how do I use that? I'm going to say angle A, I can consider writing angle A plus angle ACB, plus angle ABC. ABC is equals to 180 degrees. Don't forget the concept. After writing each and every statement should be accompanied by a reason. So that is sum of angles in a triangle. Sum of angles in a triangle is equals to 180 degrees. Then from there, the next step, that's when you substitute, right? So as you are going to substitute now, we know that our angle A, we got 68 degrees. So you can consider writing 68 degrees plus our angle ACB, we got X being 90. So you're going to say 90 degrees plus our angle ABC is represented by small letter k. Then I'm going to say equals to 180 degrees. So it means to say on this step, we are solving simply for k. Then let's add 68 plus 90. 68 plus 90 is equals to 158. So you're going to say 158 degrees plus angle k is equals to 180 degrees. Then I'm going to say angle k, it's equals to 180 degrees minus 158. Therefore, angle k is equals to, let's say 180 minus 158. 180 minus 158. We're getting 22 degrees. So it means to k is, it means to say k, angle k is equals to 22 degrees. So that is 22 degrees. Then after that, it means to say we can now consider calculating angle M. Please make sure that you follow how I calculate here so that you don't make mistakes, right? So for us to calculate angle M, I'm going to simply say angle M plus 68 degrees is equals to 180 degrees. Each and every statement should be accompanied by the reason. So this is what sum of angles on a straight line, sum of angles on STR. And then from there, you can simply say angle M is equals to, you write 180 degrees. You take that positive 68 that side, it changes the sign to become minus 68 degrees. Then therefore, angle M is an angle, put a cap on top of M, is equals to 168 minus 180 minus 68. So that is 112. So it means to say the size of angle M, that's 112 degrees. Then after getting angle M, we are left with determining angle J. So for you to determine angle J, remember this angle right here, that I'm going to show using a yellow angle, this one, we need to determine it in order to get angle J, of which there are three ways in which you can get angle J, the way I'm seeing this. So let's now solve that. So I'm just going to show you one of the ways, right? So now let's find angle J. So you finding angle J, what's going to happen? You're gonna say that angle which is unknown, the one that we're looking for, that is angle BCD. So I'm gonna say angle BCD plus angle J, not actually angle J. Let me rather write it like this. I'm seeing something. Angle BCD, the one that is unknown, is equals to angle K. Let's start there. It's equals to angle K. Reason that is gonna be alternating angles equal. Alternate angles equal. And then I'm gonna say therefore angle BCD is equals to, so we know that our angle K is 22 degrees. 22 degrees, as easy as that. After getting that, that's when you can now determine angle J. So to determine angle J, you can use sum of angles in a triangle in triangle BCD, or you can use the exterior angle of a triangle is equals to sum of two interior angles, right? So you can use either one of those. So let's say angle 68, which is the exterior angle of a triangle, is equals to sum of two opposite interior angles, which is going to be angle J that we are looking for plus angle BCD that we recently got. Angle BCD. Remember that each and every statement should be accompanied by the reason. So here you'll just say the exterior. Apologies for my handwriting, it's a bit ugly. Exterior angle of a triangle is equals to sum of interior opposite angles. And then from there, you can now continue to just say 68 degrees. It's equals to angle J that we're looking for. Put a cap on top. Plus angle BCD that we got 22 degrees. Then you're going to say 68 degrees minus 22 degrees, because when I take 22 that side, it will be negative. It's equals to angle J. Therefore, angle J is equals to what? 68 minus 22. So here we're going to say 68 degrees minus 22 degrees. I'm going to get 46. 68 minus 22, that's 46. So it means to say this should be 46 degrees. So that's how basically you solve that. So I hope you have learned a thing or two, guys. So here basically you need to make sure that you know your geometrical rider theorems. Then after knowing your geometrical rider theorems, you apply those laws that are associated with the geometrical figure that you are given. Euclidean geometry is not difficult. It's a matter of you understanding on who's teaching you maths, and you'll get a distinction at the end of the day. So that's how basically we solve this values of the unknown. You've seen how we calculate the value of x, L, angle K, J, M, and the rest of the angles. And mind you, when solving Euclidean geometry riders, there's no procedure that one follows. You start with the most given information of that particular diagram, guys. It's the one and only maths favorite teacher once again. Don't forget to subscribe and stay tuned for more.